What if you launched a car at the speed of light? Let's say you're standing in a vast desert with a shiny red sports car, freshly waxed, humming with anticipation. You've modified it with the most advanced particle accelerator technology known to humankind. And today's the day. You're going to launch it at the speed of light. Not really fast, not faster than sound. No, you're going full Einstein. 299,792,458 meters per second. Buckle up. First, let's talk about the driver, you, or rather the brave soul who volunteers to sit behind the wheel. At light speed, time dilation kicks in hard. According to Einstein's theory of relativity, as you approach the speed of light, time slows down for you relative to everyone else. So while the car might zip across the galaxy in what feels like seconds to you, billions of years could pass outside. You could leave Earth for a joyride and come back to find that humans have evolved into telepathic jellyfish, or gone extinct because someone tried to funnel Niagara Falls through a straw again. But let's not get ahead of ourselves. Before the car even moves, we hit a problem. Physics, specifically mass. As an object accelerates toward the speed of light, its relativistic mass increases. That means your car gets heavier, not emotionally, physically. At light speed, its mass becomes infinite. And to accelerate something with infinite mass, you'd need infinite energy, which is hard to find even on Amazon Prime. Let's pretend you somehow bypass that issue. Maybe you've discovered a loophole in physics or bribed the laws of nature with quantum cookies. The car launches. Instantly, it becomes a blur, not just visually, but physically. At light speed, photons don't experience time or distance. They just exist. So your car, now behaving like a photon, doesn't travel in the traditional sense. It's here, then it's there, with no in-between. GPS would be useless. Turn left in 0.0. 0.0000000000001 seconds isn't helpful. Now let's imagine the car actually moves through space. What happens to the environment around it? Air molecules don't like being ignored. At such speeds, the car would slam into them with unimaginable force. The friction would be so intense that the car would vaporize before it even left the parking lot. The atoms in the air wouldn't politely step aside, they'd explode into plasma. Your car would become a miniature sun. Congratulations, you've invented vehicular fusion. And the driver? Well, assuming they weren't instantly turned into a smear of subatomic particles, they'd experience some strange things. The stars ahead would shift into ultraviolet or even X-ray wavelengths due to Doppler shift. Everything behind would fade into infrared. The windshield would be useless. You'd need gamma-ray goggles and a lead-lined helmet just to see where you're going. Also, your dashboard would melt. Probably. Let's say you're driving toward Alpha Centauri, our nearest star system. It's about 4.37 light-years away. At light speed, you'd get there in 4.37 years, unless you're the driver, in which case it might feel like a few seconds. You arrive, step out, and realize you forgot your passport. Also, Earth is now ruled by sentient AI toasters. Oops, but wait, what about the car itself? Can it survive the journey? Not likely. At light speed, even a single hydrogen atom in space becomes a deadly projectile. The car would be bombarded by high-energy particles, each one capable of punching through metal like a bullet through butter. You'd need shielding thicker than a mountain, which would make the car heavier, which would require more energy, which brings us back to infinite energy. Again. Let's rewind. Maybe instead of launching a car at light speed, you just try to accelerate it to 99.9999% of light speed. That's more realistic. Kind of. At that speed, time dilation still kicks in, but you avoid the infinite mass problem. Sort of. You still need absurd amounts of energy, like drain the entire planet's power grid for 1,000 years. levels of energy. And even then, the car would probably disintegrate from the stress. So, what's the takeaway? Launching a car at light speed is a fun idea. It's the kind of thing you dream about while staring at the stars or watching sci fi movies. But in reality, it's a physics nightmare. Time dilation, infinite energy, vaporization, cosmic radiation. It's like trying to drive through a black hole with cruise control on. Still, it's a beautiful thought. A car gleaming in the void, racing faster than anything ever has. A symbol of human curiosity, defiance, and love for speed. Just don't forget to buckle your seatbelt. And maybe bring a fire extinguisher, or a spaceship, or a new universe. Because if you ever do manage to launch a car at the speed of light, you won't just break the sound barrier, you'll break reality.